Hello everyone, welcome to my channel. Today we quickly want to solve this equation. S to the power of 4 is equal to minus 9. This S to the power of 4 is equal to minus 9. Now to solve this equation, we want to start with the first step. Now what we are going to do is to first rearrange this equation. That is, we have the equation S to the power of 4 is equal to minus 9. Then to solve this, let's isolate S to the power of 4 by adding 9 to both sides of the equation. If you add 9 to both sides of this equation, then this equation become S to the power of 4 plus 9, which is equal to 0. If you add 9 to both sides of this equation become S to the power of 4 plus 9 is equal to 0. Now, we can now move to step 2. Then in step 2, we want to solve for S to the power of 4. We now have the equation S to the power of 4 plus 9 is equal to 0. Then this can be rewrite as S to the power of 4 is equal to minus 9, which is the initial or the original equation given. Then which leads us back to the original equation, as we can see now that S to the power of 4 is equal to minus 9. Now in step 3, we recognize that there are no real solutions. That is, at this point, we observe that S to the power of 4 is always non-negative for real value of x, since raising any real number to the power of 4 result in a positive or zero value. However, the right hand side is negative, meaning there are no real solution to this equation. We can see that the left hand side is this and the right hand side is this, which is negative, and this shows that there are no real solution to this equation. Then in our step 4, we solve the equation in complex number domain. Let's solve in the complex number domain. That is, to find the complex solution, we need to express minus 9 in form polar form, and then take the fourth root. Then what do we do? Now to express this, we have expressed minus 9 in polar form. We can write minus 9 as minus 9 is equal to 9 multiplied by e to the power of I pi. Then we are writing this in polar form. Then where e to the power of I pi, this represents the direction of the negative real axis from Euler's formula. Then step 4.2, we want to find the fourth root now. Exponential I to the power 9 e to the power of I pi. Then use the Demoivre's theorem. We want to make use of the Demoivre's theorem. The general formula for the nth root of the complex number is given as r to the power of 1 divided by n bracket cos bracket theta plus 2k pi divided by n bracket plus I sine bracket theta plus 2k pi divided by n bracket and then the close bracket. Then r is equal to 9. As you can see from the equation, r now is 9. Pi theta is equal to pi. Theta is equal to pi. N is equal to 4. And then k is equal to 0, 1, 2, 3. It ranges from 0, 1, 2, 3. Now, the magnitude r to the power of 1 divided by 4 is r to the power of 1 divided by 4 is equal to 9 to the power of 1 divided by 4, which is equal to fourth root of 9. This can be written as fourth root of 9, which is equal to square root of 3. Now, for each k, we find the angle. Now, for each k, we can now find the angle. Then n plus 2 k pi divided by 4 is equal to bracket 1 plus 2k, then bracket pi divided by 4. For k is equal to 0, 1, 2, 3. Then for k is equal to 0, 1, 2, 3. Now, step 4.3, we compute the root. At this point, what we need to do is to compute the root. Then for k is equal to 0, we know we want to compute the root. For k is equal to 0, 1, 2, 3. Then for k is equal to 0, we have s1 is equal to square root of 3, open bracket, cos bracket pi divided by 4, you close it, plus I sine pi divided by 4, open bracket, pi divided by 4, close bracket, then we close it, is equal to square root of bracket, square root of 2 divided by 2, plus I square root of 2 divided by 2. Then we close the bracket. Then what we do now is S1 will now be equal to square root of 6. All of this will be, if you say square root of 2, square root of 3 multiplied by square root of 2, that will give you square root of 6, then divided by 2, plus the square root of 3 multiplied by the square root of 2 will give you I square root of 6 divided by 2. Then also for k is equal to 1, we have x2 will be equal to square root of 3 bracket cos bracket 3 pi divided by 4 bracket plus sine plus I sine bracket 3 pi divided by 4 bracket, then we'll close the bracket. All of these will be equal to square root of 3 bracket minus square root of 2 divided by 2 plus I square root of 2 divided by 2. Then S2 will now be equal to minus square root of 6 divided by 2 plus I square root of 6 divided by 2. So for k now is equal to 2. For k is equal to 2, S3 will be equal to square root of bracket cos bracket 5 pi divided by 4, then bracket plus I sine bracket 5 pi divided by 4 bracket, and we close all the bracket. The whole of this will be equal to square root of 3 minus square root of 2 divided by 2 minus I square root of 2 divided by 2. Then we close the bracket. Then if you multiply out the whole of this, we have x3 will now be equal to minus square root of 6 divided by 2 minus I square root of 6 divided by 2. Because here we have square root of 3 outside the bracket, then minus here square root of 2 divided by 2 minus I square root of 2 divided by 2. Then after the whole of this, when you multiply the square root of 3 multiplied by 2, this will give you square root of 6, and there is minus here, that is minus square root of 6 divided by 2. Then here there is minus I. If you multiply by this square root of 3 and square root of 2, it will give you minus I square root of 6 divided by 2. Now for k is equal to 3 now. For k equal to 3, then we can now solve for x4. x4 is equal to square root of 3 bracket cos bracket 7 pi divided by 4 bracket plus I sine bracket 7 pi divided by 4 bracket, and we close the bracket. So the whole of this will be equal to square root of 3 bracket square root of 2 divided by 2 minus I square root of 2 divided by 2. If you multiply square root of 3 by the whole of this, then we have x4. x4 will be equal to square root of 6 divided by 2 minus I square root of 6 divided by 2. So, and these are the final answer. We can see that we've got the value of x4, then x3. Also, we have our x2 and then x1. This the final answer. Therefore, our final answer, the four complex solution for this problem, x to the power of 4 is equal to minus 1, x1 is equal to square root of 6 divided by 2 plus I square root of 6 divided by 2, then x2 is equal to minus square root of 6 divided by 2 plus I square root of 6 divided by 2, and x3 is equal to minus square root of 6 divided by 2 minus I square root of 6 divided by 2, and x4 is equal to square root of 6 divided by 2 minus I square root of 6 divided by 2. I hope you enjoyed the video. Thank you for watching. Please don't forget to like, share, comment, and subscribe to my channel. Bye.